In this video I'm looking at the solution to question 7 of the June 2011 Edexcel M1 paper. The question is about vectors. So the question starts by telling us that I and j are to be unit vectors due east and due north respectively, and positions vectors are given relative to an origin O. So two ships P and Q are moving with constant velocities. Ship P moves with velocity given by 2I minus 3j, and ship Q moves with velocity 3I plus 4j, and these are in kilometers per hour. First part of the question was simply to find the bearing on which Q is moving. Then goes on to say that at time 2 p.m. P is at a point with position vector I plus j, and Q is at a point with position vector minus 2j. Time t after 2 p.m. the position vectors of P and Q are given by vector P and vector Q, and we're asked to write down expressions for these two vectors P and Q, so the position vectors of the ships, and then from those to find the vector PQ. The question then goes on to ask us to find the time at which Q is due north of P, and also when Q is northwest of P. Well, the first part of the question then is one of just working out a bearing of P. We're told in the question that the velocity of P is equal to 2I minus 3j. And the velocity of Q is equal to 3I plus 4j. So for this one we're looking at the bearing of Q, so we're looking at the 3I plus 4j. In other words, we're simply asked to work out for our vector, which is 3 along and 4 up, the bearing. Now the bearing is obviously the angle from north, so we're looking at this angle in here from north, so the bearing comes from tan to the minus 1 of 3 over 4. And that comes to 37 degrees, or as a bearing 037 degrees. Two marks in that part of the question, a method mark and an answer mark. You'd probably get that just for stating 37 degrees, but if you can remember, the bearing should be 3 figures. In the second part of the question then, we're using this general idea that the position vector of a point R will be its initial position, let's call that R0, plus the velocity multiplied by time. So that the position of P will be its starting point, so P is equal to the starting point, which we're told is at I plus j, and then plus its velocity, which is 2I minus 3j multiplied by t. And we can leave the answer like that. There's no need to do anything else, we'll just ask for an expression. In a similar way, Q is equal to its starting position minus 2j, and then plus its velocity, which is 3I plus 4j multiplied by t. PQ, well, remember that this is always going to be Q minus P. So it's the vector that we've just calculated for Q and then minus the vector for P. So if we do that, we get minus 2j and then minus j from above, so minus 3j. and in the I component we're going to have minus I, so minus I minus 3j, and then those that are multiplied by t, we have 3I minus 2I, and also then 4j and minus negative 3j, and they will be multiplied by t. So just tidying that up a little bit, we get minus I minus 3j, and then plus I and 7j multiplied by t. The marking here was to be an M method mark and an A mark for each of the expressions 1 and 2, so for P and Q, and then a method mark and an A mark for getting the answer for the vector PQ. As I said, there's no need in this particular question to do anything to rearrange this in terms of the value of I and the value of j separated. In some questions you would need to do that, however in this one you don't. Going on to the final part of the question then, we're asked to find when Q is due north of P and Q is northwest of P. We can find that from the vector PQ. Now to do this I have in fact rearranged it to write it as t minus 1I and 7t minus 3j. That's just a simple rearrangement of the PQ that we found in part B of the question. The reason for doing that is that we can interpret this now as the position of P relative to Q, and if Q is due north of P, then we can say that the vector PQ must have I component which is 0. In other words, it's not, if it's due north would mean that the easterly part of the vector is 0. So the I component is 0, which implies that t minus 1 is equal to 0, and therefore t is equal to 1. Now remembering that we're starting off at a time 2 p.m, this means that this happens at 3 p.m. In the second part of the question, northwest is over in this direction, PQ, so that we have an I component which is going to be negative of the j component. So these are going to be equal values. So the I component is equal to negative of the j component. Or in other words, t minus 1 is equal to negative of 7t minus 3. Rearranging that, we get 8t. 8t is equal to 4, and therefore t is equal to 1/2. Putting that into a time, in other words, it's 2:30 p.m. Four marks for this part of the question. They were an M1 and A1 for part 1 and M1 and A1 for that second part too. Well, that concludes the solution to this question. Solutions to other questions can be found at www.furthermaths.org.uk.